All right, so this is a review lesson on adding and subtracting fractions, as with the last video. Hopefully this sounds familiar. But in general, if you want to add or subtract fractions, you first need to make sure you have a common denominator. So first I'll say find and not just any common denominator, but ideally the lowest common denominator. And since lowest common denominator has a lot of syllables and we tend to get kind of lazy, sometimes we just say LCD, the lowest common denominator. If you already have a common denominator when you're adding or subtracting fractions, it's exceptionally quick. And the only time it's not so quick is when we don't have that lowest common denominator. So if I look at this, 3 over 4 or 3/4 plus 5/6, I have different denominators. So I have 3 of these quarters, I have 5 of these sixths. To add them together, I need to find a common denominator. Now, 24 is a common denominator, but it's not the lowest common denominator. The lowest common denominator of 4 and 6 is 12. That requires knowing your 4 and your 6 times tables quite quickly. So essentially, I want to change this 4 to a 12, which I can do as long as I realize, how do I go from 4 to 12 in terms of multiplying? Because I can change any fraction to an equivalent fraction if I multiply the top and the bottom by the same number. So to go from 4 to 12, I times by 3. So as long as I do the exact same thing to the numerator, I come up with a different but equivalent fraction. So 3 times 3 is 9. So instead of 3/4, I'm thinking about that as 4, helps so I can speak. Instead of 3/4, I'm thinking of it as 9/12. Similarly, to go from 6 to 12, I've got to times it by 2. So I can change that 6 to a 12 as long as I do the exact same operation to the numerator. So 5 times 2 is 10. And so instead of literally adding 3/4 plus 5/6, I'm going to add 9/12 and 10/12 because now I have that common denominator, which means my answer is going to be in terms of 12ths, because once you have a common denominator, it's just 9 plus 10, which is 19. Now this answer here is great, but it's called an improper fraction. Nothing really wrong with it. Don't get thrown off by the word improper. It's not wrong. It's just a little bit tough to visualize, 19/12. And in general, we're encouraged at this level to change it to a proper fraction, or a mixed number, I really should say. And so 19 is bigger than 12, which means this number is more than one whole. And so it's a little bit easier to visualize if we take out any whole values. So 12 goes in the 19 one whole time. And so instead of writing this as 19 over 12, I want to write this as 1 and something. What's the something? Well, if I took away 12 from 19 once, I have only 7 left in my numerator. I took away 12 to make that whole. And so I used to have 19/12. 12 of those 12ths I took away to make my one whole, which means I have 7/12 left. And this is what we call a mixed number. And it's generally considered to be simpler, especially at this level. I will say, though, in future grades, we kind of want to just leave it like that, because an improper fraction, we'll see, is actually quite often more helpful in terms of calculating, but it's very often more difficult to kind of understand what it means. It's easier to visualize 1 and 7/12, most likely than 19/12, but they are equivalent. And so again, most of my work was not adding. Most of my work here was actually finding that common denominator, ideally the lowest common denominator. Often, it's helpful to change mixed numbers into improper fractions. But you don't have to. Just often it's helpful. So for example, I'm going to work this out in 2 ways. One by changing both these mixed numbers into improper fractions, one without. And so for example, if I want to change 2 2/3 into an improper fraction, what always works is multiply the numerator times, sorry, I said that wrong, multiply the denominator times the whole number, which is 6, and then add that to the top. So I get 8. So 2 2/3, same as 8/3. 8/3 is equivalent to 2 2/3. And again, that always works for any mixed number. And so 1 and 5/6, go 1 times 6 is 6, add it to the top, you got 11, so 11/6. So 2 2/3 minus 1 5/6 is equivalent to 8/3 minus 11/6. Now again, I didn't actually have to do that, and I will mention afterwards another approach, but this always works. And if you're not sure about how to approach operations with mixed numbers, it's never a bad idea to change it to improper fractions, or it's always possible. Now again, I am subtracting. I need to find a common denominator. I need the lowest common denominator of 3 and 6. Again, if you just multiply them together, you get 18, but 18 is definitely not the lowest common denominator. The lowest common denominator of 3 and 6 is 6. And so if I do that, I only have to change this one denominator to 6, which means I doubled 3 to get 6. I need to double the numerator to get 16. And now I actually perform my subtraction step. 16 subtract 11 is 5 over 6. And I'm done. There's my answer, 5, 6. It's already in lowest terms. It's not an improper fraction. All good. That said, I didn't actually have to change these mixed numbers into improper fractions. So let me just kind of show another approach. And ideally, both make sense. OK, so let me write this down again. 2 and 2/3 minus 1 and 5/6. OK. Another thing I could do right away is just first subtract my whole numbers. 2 take away 1, which is 1. Okay, that's a nice start. And then focus on my fractions. Now subtract my fractions. 2/3 minus 5/6. So 2/3 minus 5/6, I need to find a common denominator there. So I'll change this 3 to a 6. Again, I'm focusing on just the fractions part now. And so I doubled the denominator, so I need to double the numerator. And so I have 4 over 6 minus 5 over 6. This is where we got to be careful. Because 4 minus 5 is not 1. 4 minus 5 is negative 1. So I get 1 and negative 1/6. Which, what does that mean? I mean, if we know what this means, then we're going to be done in a second. But this is not a good way to leave our answer. Our answer is 1 and negative 1/6. Well, this does mean something. This means our answer is 1 whole minus a 1/6. This is literally the same as 1 whole take away a 1/6. And so 1 whole take away a 1/6 is, the same as 6/6 minus one of those 6 is just 5/6. And so in the end, this does equal the same thing as before, which makes sense. It's the same question. But if I look at both, I would say the top one, by changing everything to a mixed number, is easier to explain. But the bottom one was less work. And so in the long run, I like both. But you just got to be careful. And in the earlier stages of learning this, I generally recommend just changing everything to an improper fraction, at least at first. But as we get more proficient, I do recommend not doing that necessarily. And in this case, as 1 and negative 1/6 looks kind of weird. If we know what it means, though, it literally means 1 take away a 1/6. We can get to that 5/6 a little bit faster.